Hello Internet, this is your daily dose of data science. Today we are going to create a class that defines polynomial functions as objects in Python. Please subscribe and let's begin. A polynomial is a function that takes this form. They are constants multiplied by variables, and the variables have their powers increasing. A good example of a polynomial is 4x cubed plus 5x squared plus x equals to 10. I have written this in LaTeX. You can look at the link in the description on how I wrote this. So this is a polynomial of degree n, and this is a polynomial of degree 3. Polynomial of degree 3, where 3 is the maximum power that you can see in that polynomial. So we want to create a class that will be accepting a variable x given a particular polynomial and can be able to evaluate the polynomial on that variable. We know that polynomials have several, there are infinite polynomials that you can create in the universe, and we want to be able to give the user of our class the flexibility of creating their own polynomial. So we are going to create a class, and we are going to call this class create polynomial function. Then it's good to leave doc strings in your class so that someone can understand what your class is doing. We are going to write the doc strings later. Then we are going to define a constructor. So a constructor is a function that is first called when you are creating an object from your class. So here, when we look at this, what we need to define are, whenever you're defining or you're creating a polynomial, is to know these weights, and we're going to call these weights coefficients. So we need coefficients, and we also need the degree, because each polynomial has the degree. This is polynomial of degree n, and this is polynomial of degree 3. So I will need a degree here. Degree, and the degree is an integer. So I'm using typing to make sure that anyone who is going to look at the definition of this class knows what is expected as arguments. Then coefficient. The coefficients are, we are going to accept list, so it will be a list of coefficients. In this case here, the coefficients will be 4, 1. The coefficient of x here is 4, 5. The coefficient of x here is 1, and then there is no coefficient of x here. Yep, so we will expect coefficients 4, 5, 1, 0. 4, 5, 1 and 10. It is 4, 5, 1 and 10, because the x here is to power 0, so the coefficient here is 10, which is the constant. My brain kind of froze there. So this, then we need to instantiate this in our class. So self.degree is going to be, so this still is an integer and is going to be the degree variable that is passed. Then self.coefficient is the list, and we are picking the coefficient variables that that was passed here. So based on the degree, we can determine the powers. The powers, I mean these 3, 2, 1, or the exponents of each term. So this term here has x has an exponent of 3, then this. So I'm going to create powers. I'll just call it powers, and it should be a list, and it should be computed from the degree. So we want to get, if we are given degree 3, we want to get a list of values from 3 going downwards to 0. And since we are in Jupyter, the reason why I'm coding this in Jupyter is so that I can experiment. Let me do list comprehension here. For I in range. So assuming the degree was 3, I have 0, 1, 2. I would like to have 3, 2, 1, 0. So let me do from 3 to 1, and the step should be, I mean to -1 here, and the step should be -1. Yeah, so here we have 3, 2, 1, 0. So this is what we expect here. But now the degree, the 3 is the degree. Now that we have the powers, we can now look at the coefficients that are passed by the user, and the number of items in the powers. We expect them to be the same. So the coefficients here would be, for example, 4, 5, 1, and 10, which are 1, 2, 3, 4 coefficients. And we have seen the exponents, or the powers. Let me call them exponents. The exponents are 3, 2, 1, 0. They are also 4. So we expect the number of items in this list should be equal to the number of items in this list. But if they are not equal, then we should not create the object, and we should throw an error telling the user that the items are not satisfying that condition. So we're going to check the length of the coefficients here. And we are going to check if it is not equal to the length of the exponents. If they are not equal, I'm going to pass in a message. The message here is just a string. It's a variable with a string, and the message we are going to pass is number of coefficients is not equal to the number of exponents. I think number of coefficients, we should add a variable here that gives us that number of coefficients, then we put into bracket, then we add this. I want to use string interpolation. I'm going to use multi-line string so that it can fit. Yep. So number of coefficients, this is not equal to the number of exponents, and the exponents are this. Yeah, so then we are going to have it to raise. So we are going to raise an exception. Let's raise a value error. raise value error, the spelling of value error. In the value error will take in a message, so it will output the message, and that is much to do with the constructor. For each class that you create, it's advisable to have a dunder reproduction the way you can reproduce the class from a function that helps you to be, that helps the, I don't know, I am struggling with this, it's self-explanatory in my brain. This function here that helps the developers know how to reproduce the class that you've created. So this is the function itself. It should return a string. I don't know if this is right, but we shall test it. So this should return a string that shows you how you created that class in the first place, or how you created the object. So it should be that, and the first argument and the second argument. The first argument is degree equal to, later when we are testing what we have created, you will see how this comes into place. So this is self.degree, and then this is self.coefficients. Yep, let me make this bigger so that we can see it. So this is important to have when you're defining a class or when you're creating a class. We also need a string. The string function helps you to print or to show what the class is all about in a readable format. Also returns a string, return, and the string, I want it to return this as the polynomial. So let me try to generate it. So I'm going to generate terms from whatever we have here, so that a term is like 4x to power 3, 5x squared, x 10x to power 0. So I'm going to put them in a list, terms list, and this is going to be a list comprehension. So I'm going to have something for something. Let me just put here for C in a zip of coefficients and powers, so coefficients and exponents, I mean. So I have here coefficients and exponents. So what am I doing here? I'm trying to create, whenever someone is printing an object that is created from this class, it should be able to return this. And for us to return this, I want to first create term by term based on what we have. So this zip that you're seeing here will help us get 4 and 3 in the same tuple, 5 and 2 in the same tuple. Then I can use it to create this string here as a term. So when we zip, the first item in the zip is the coefficient, which is c, and the second one is an exponent. I'm going to use e. Then the term is going to be the coefficient first, which is c, then x, then to power I'm going to use that, and then the exponent, which is e. So here we're going to have a terms list, and this terms list, I want it to, I think we should first return this. So here we have the terms. I'm going to join all of them to create just one string. Terms list here. So this will join each term. Remember, we have created each term here with the plus to create only one string. Let's create this and we test it out before we continue. So I have my func is going to be create polynomial function, and its constructor here takes in degree. I'm going to use degree 3. Let's use the same coefficients here: 4, 5, 1, 10, 4, 5, 1, 10, and that function is created is saying that type error, create function 3 has takes no argument. Oh no, I think it takes arguments. Done init. Create polynomial function 3. Let me run this again. I can't tell where the problem is coming from. There is, it takes in self, degree is an integer, then coefficient is an integer, degree list, this is a list, this is a list. I don't know why it is saying that this does not take create polynomial function takes no arguments. Really, I think it's because of the constructor. It should be double underscore here. Let's continue. This should be double underscore. That's the reason why this was failing. So we have function. If we want to print to show how to create the function, you can run that, and it shows us that this function was created degree 3 and coefficient that. So what has helped us to generate this text is this function here, the repro or reproduction, whichever thing you want to use it. Then if I want to print the function itself, that object, it will give me this, which shows us 3 to power x cubed 5x, and that. I don't like this. I want us to remove this x to power 0 so that we can see it like this. So what we are going to do is to come back to this string, and I'm going to add stuff in this string interpolation, string compression, sorry. And what I'm going to add first is I want this to happen if p is not equals to 0, if p is not equals to 0, or if exponent is not equal to 0. So if the exponent is not equal to 0, what should we output? We are going to output this without the x. We're going to just output the constant. And also if one of the coefficient is 0, for example, if I put here 0 and I run this and I run this, you will see that there is 0x to power 1. We don't need this. Then I'm going to say we also want it if the coefficient is not equal to 0. So we will have all the terminology, all the terms, provided c is not equals to 0, and also we have all the terms like this, provided e is not equals to 0, and if e is not equal to 0, we shall only have the constant in the term. Yep, so let's run this and we see what we are getting, which is impressive. What if we had negative value here? What will it print? We are saying it printing plus and minus 10 here. So what I'm going to do is to replace, because it is a string, you can do a string replace and replace plus and minus with this plus, this plus minus with minus. So when I run this, we can have that. So this is a better way of representation of the object that you've created. So this is the object that you've created in mathematical form. So now let's define a function that will be evaluating the object that we've created. If we pass in x, what should be the value that comes out, or the value that is returned? I'm going to call this function evaluate, and evaluate takes in all the objects from self, and it takes also a variable, and this variable is an integer. There is a docstring here. We are going to find what to write there later. So what we want is to evaluate this, and this will mean if, for example, I pass here 2, it will be 4 times 2 cubed, 4 times 2 cubed plus 5 times 2 square plus 2 plus 10. So that means that we are working with a sum equal to 0. Let's start from 0. Then we are going to again use zip for coefficient and an exponent in the zip. The zip function just gives us tuples based on the indexes of the items in the iterable. So the first item will be the coefficients list, so self.coefficient, and then the second item will be the exponents, self.exponents. Yep, for those we are going to add to sum, and what we are going to do is the constant, just the way you're seeing the terminology, the terms here, the constant times the variable times the variable that is passed here, but the variable will be raised to power of the exponent. Yep. And then we are going to return sum. Let me call this SM to mean sum, because sum is defined variable. So this is how we are going to create the polynomial class, and let's now try to use it. But before we use it, let's write the doc strings. So this is a function that evaluates the polynomial, evaluates the polynomial, the parameter is a variable, the variable to be used to evaluate the polynomial. Yeah, the variable to be used to evaluate the polynomial, and then it returns an integer. Then we have another docstring here, and this docstring are going to say that it is a class that creates polynomial functions, then I'm going to put these underscores here. So parameter degree is the degree of the polynomial, then another parameter coefficients, say they are the coefficients of the polynomial. Well, now our class is complete, I think. Then we can now run this, and then we can try to evaluate func with the 3. Error. This is not callable, which is true. We're supposed to use evaluate function, so we're going to do dot evaluate, and we're going to evaluate it with 3. Local variable sum referenced before assignment. Yep, where are you? This it should be sm run create evaluate. We have 143. So we can do we can just play with these functions. We can create another one. I'm going to create func2, and func2 will be a polynomial of degree 4, and this is going to be having like 5 values, so I'm going to have 89 there. So we can do func2.evaluate .evaluate, and we're going to evaluate it with the 10, and this is the value of that. But we may want to see how is this func2 looking like, so I'm going to print it to see the polynomial itself. It is 4x to power 4 plus 5x cubed minus 10x plus 81. I want if it is x to power 1, it should just be x, not x to power 1. How possible can we do this? Can we in the string here? No, let's leave it now. We should let it be your exercise. Find out how to remove this to power 1, and leave your comment in the description. If you've learned something, please consider subscribing. Until tomorrow, learn something, teach someone. Bye.